In this video, I will talk about how categorical independent variables are handled in regression analysis. So far, the examples we have considered have involved quantitative independent variables, such as the miles traveled and the number of deliveries in our trucking company example. In many situations, however, we must work with categorical independent variables, such as marital status, such as married or single, or method of payment, such as cash, credit card, or check, and so on. To illustrate the use and the interpretation of categorical independent variable in a regression model, we'll again consider the trucking company example. So several of the trucking driving assignments require the drivers to travel on a congested segment of a highway during afternoon rush hour. The management believes that this factor may also contribute substantially to variability in travel times across driving assignments. So how do we incorporate information on such driving assignments, which includes a travel on congested segment of a highway during the afternoon rush hour? How do we incorporate that into our regression model? So the previous independent variables we have considered are miles traveled and number of deliveries. They both are quantitative. But this new variable rush hour is categorical and require us to define a new type of variable called a dummy variable. Dummy variable is a variable used to model the effect of categorical independent variables, and it has only the value 0 or 1. So to incorporate the variable that indicates whether a driving assignment is a highway rush hour driving or not into our current model, we would define the rush hour like this. Rush hour x3 equal to 0 if a driving assignment did not include travel on a congested segment of highway during afternoon rush hour. Rush hour x3 equal to 1 if the driving assignment included the travel on the highway during rush hour. Will this dummy variable add valuable information to our current regression model for the trucking company? Using the Excel chart tools, we can create a frequency distribution and a histogram of residuals to help us make an initial assessment. We first create a histogram for driving assignments that included highway rush hour driving. And then we create another histogram to represent the residuals for driving assignments did not include highway rush hour driving. The histogram on the left, which included highway rush hour driving, tend to have more positive residuals, which means that the actual driving time is greater than the predicted time. So which means that we are generally under predicting the travel time for these driving assignments. On the other hand, in this histogram for driving assignments not including the highway rush hours driving tend to have a negative residuals, which means that actual driving time is less than the predicted driving time. That means we're generally over-predicting the travel time for these driving assignments. This result suggests that the highway rush hour dummy variable could potentially explain a substantial portion of the variance in travel time that is unexplained by the current model. So we proceed by adding the dummy variable x3 to the current regression model. Using Excel's regression tool, we can develop the estimated regression equation like this. We can see that the coefficient for the intercept, miles, and deliveries and highways. So we can form the equation. So we can interpret this model as the mean travel time of a driving assignment increases by 0.0672 hours for every increase of 1 mile traveled, or 0.6735 hours for every delivery, or 0.9980 hours if the driving assignment route requires the driver to travel on the congested segment of a highway during the afternoon rush hour period. In addition, we see that R squared is 0.8838, which is higher than the previous model where we only used the number of mile travel and the number of deliveries. This means that this new equation should prove helpful in estimate the travel time necessary for various driving assignments. To understand how to interpret the regression when a categorical variable is present, let's compare the regression model for the case when the driving assignment does not include highway rush hour driving and when it includes the highway rush hour driving. When x3 equal to 0, we have an equation of y equals to negative 0.3302 plus 0.0672 multiplied by x1 plus 0.6735 multiplied by x2. So when x3 equal to 1, notice that the intercept actually changed a little bit because we have the value 1 in here that adds the 0.9980 to the intercept. So then the equation becomes y equal to 0.6678 plus 0.0672 multiplied by x1 plus 0.6735 multiplied by x2. So this portion is the same between the two equations. The difference is between the intercept, and that difference is 0.9980, which is the coefficient for the highway categorical variable. So that means 0.9980 is the difference between the mean travel time for the driving assignments on highway rush hour versus the mean travel time for driving assignments that do not include the highway rush hour driving. In effect, the use of a categorical or dummy variable provides two estimated regression equations that can be used to predict the travel time. One that corresponds to driving assignments that include the highway rush hour driving, and the other one do not include such travel. The categorical variable for the trucking company example has two levels, right? So driving assignment include the highway rush hour driving and the one without. However, when a categorical variable has more than two levels, so we must take care of both defining and interpreting the dummy variables. If a categorical variable has k levels, k minus 1 dummy variables are required, with each dummy variable corresponding to one of the levels of the categorical variable encoded as 0 or 1. For example, a manufacturer organized the sales for a particular state into 3 regions, A, B, and C. The managers want to use the regression analysis to help predict the number of the products sold per week. With the number of units sold as the dependent variable, they're considering several independent variables, such as the number of sales personnel, advertising spending, etc. The manager believes that the sales region is also an important factor in predicting the number of units sold. Because sales region is a categorical variable with 3 levels, A, B, and C, we will need 2 dummy variables to represent the sales region. So we select region A to be the reference region. Each dummy variable can be coded 0 or 1 as in this table. So we can see that region A is coded as 0, 0, and B as 1, 0, and C as 0, 1. We only need 2 to represent 3 regions. The regression equation relating the estimate mean number of units sold to the dummy variable is written as y equal to b0 plus b1 times x1 plus b2 times x2. So for the observations corresponding to region A, and we have the x1 equal to 0 and x2 equal to 0, just like previous table shows. So the estimated mean number of units sold, which is our predicted results or our dependent variable, is y equal to b0 plus b1 times 0 plus b2 times 0. And that means y equal to b0. So that is the y-intercept. When the observation corresponds to region B are coded, so then x1 equal to 1, x2 equal to 0. So we put it into the equation, and we have y equal to b0 plus b1. And similarly, observation corresponding to region C are coded as x1 equal to 0, x2 equal to 1. So the equation will be y equals to b0 plus b2. So 2 dummy variables were required in this example because sales region is a categorical variable with 3 levels. The assignment of the specific variables is arbitrary. The important point to remember is that when a categorical variable has k levels, k minus 1 dummy variables are required in the multiple regression analysis. Therefore, if the sales region sample has a fourth region labeled D, then 3 dummy variables would be necessary. Dummy variables are often used to model seasonal effects in sales data. If the data are collected quarterly and we use winter as the reference season, we may use 3 dummy variables defining the following matter. x1 equal to 1 if it's spring, 0 otherwise. x2 equal to 1 if summer, 0 otherwise. x3 equal to 1 if fall, 0 otherwise. So then we know what is the winter. Winter would be 0, 0. So 3 dummy variables we require here because season is a categorical variable with 4 levels. You can apply this easily to weekdays, months, etc. So next you can check out my video demonstrating how to handle categorical independent variable into a regression model for the trucking company.